Today we're going to talk about sequences and functions and how to develop equations for sequences and functions. So sequence and function are just synonyms for relationship. There's a relationship that's happening between two variables. And so the variables we're usually talking about is an input variable versus an output variable. In other words, an x versus a y. So it's a relationship between two variables, between two unknown things, and they can vary. So as one changes, the other one is going to change. So we can describe these with what's called a arithmetic sequence, arithmetic pattern. So let's talk about some patterns that we see. So take a look at these numbers and see if you can see the pattern. And if you can, give me the next three numbers. So hopefully you found it's 20, 24, and 28. So what are we doing each time? We're adding 4 each time. But the first term is already 4. So that means we can start at 0. That's important. So we have to think about the starting point, which I know the first number is 4, but we got to think about, did this pattern originate at 0? Did it originate at 0? And this pattern is, if I go backwards one term, it would be 0. Okay, let's talk about the next one. 5, 8, 11, 14. What's happening every time? Sure, I get that. Okay, so we are doing 17, 20, 23. So what do we have every time? We're going to add 3 each time. But is our pattern starting out at 3? If I go backwards one step, would I be at 3? No, I'd have to be at 2. If this pattern is 3, to keep that same pattern, it would not be starting at 0. This one would be starting at 2. So we need to add an additional 2. Okay, let's talk about 10, 16, 22, 28. What's happening between? So it would be 34, 40, 46. What do we have every time? We're going to add 6 each time. Is our pattern starting out at 6? No. If I go backwards, I would be starting at 4. We would have additional 4. Let's do the next one. The last one, 35, 43, 51. What's happening every time? There's an 8 every time. So we're going to add 8 each time. Is our pattern starting out at 8? Where would I be starting out at? -5. Right, I'd be below 0. Additional -5. An arithmetic sequence always has a starting point. So when I'm talking about starting point, let's see if I can get this clear. I'm talking about starting point. This number that I'm putting here is our starting point. Where are we originating at? So it has a starting point and a constant rate of change. This constant rate of change would be this in between each term, but my starting point would be this part right here. So we have a starting point and a constant rate of change. That's called an arithmetic sequence. What we're going to do now is we're going to take each pattern and we're going to make an equation out of the pattern. So we're going to take each one of these and create a pattern out of them. So I'm taking the first one. We've already done this. It was 20, 24, 28. And notice in each case, the rate of change is what is changing between each number. In this case, it's 4. So my rate of change is 4. 4 is my rate of change. But what's happening is I'm going to develop a rule. So I'm doing the rate of change times my input number, which is x, plus any extra needed to equal the first term. This is also called that starting point that we already referred to. So that's called the 0th term. So we're going to take our function, which we're going to call f of x. That's another symbol for function. In other words, rule. Function is another word for rule or pattern. We're going to call this, the function is the rate of change 4 times x plus what additional did I need to get to that first 4? Nothing. Because if I go backwards of 4, I would start out at 0. So why is this the rule? Because this rule will help us get any one of these numbers. If I want to find the 10th number in the sequence, I would just do 4 times the 10th number. The x is the term number. So that x is that term number. The x is the term, the 4 is my rate of change. So let's try the 10th number. If I want to find f of 10, the 10th term, in other words, the 10th term, I'm going to do 4 times the 10th term, and that would give me 40. So the 40th number in the sequence is 4, the 10th number in the sequence is 40. If I want to find f of 20, the 20th term, I would do 4 times 20, which would give me 80. If I want to find the 100th number, I would do f of 100, which is 4 times 100, which would be 400. So if I want to find any specific number, well, let's say if I want to find the 27th term, I would do 27 times 4, plus nothing. Let's try the next one. If I take the pattern 5, 8, 11, 14, remember we already found it was 17, 20, 23. So the rate of change is 3 because that's the constant rate of change that's happening between each term. So that's 3. The y is the value of the term, x is the term, 3 is the rate of change, and if I go backwards a rate of change, where would I originate from? I would originate at 2. So 2 is the extra value needed to make the first term. So it's f of x equals rate of change 3 times x, which is any term we want, plus any extra needed, which is 2 in this case. So this is the extra needed, and the 3 is the rate of change. So if I want to find f of 10, I'm going to do 3 times 10 plus 2, which would give me 32. If I want to find the 20th term, I would do 3 times 20 plus 2, which would give me 62. If I want to find f of 100, which is 3 times 100 plus 2, which would be 302. But this is my function rule to generate any one of these. Like if I want to find the fourth number, 1, 2, 3, 4. 4 times 3 is 12 plus 2 is 14, and my fourth number is 14 right here. This function rule will generate any term that I want. See if you can do the next one by yourself and then check it. My function rule this was 34, 40, 46. So my rate of change is 6, and I'm going to originate at 4. So it's f of x equals 6 times x plus 4. So f of 10, which would be 6 times 10 plus 4, which is 64. F of 20 6 times 20 plus 4, which is 124. And f of 100, the 100th number in the sequence, is 6 times 100 plus 4, which was 604. So y is my value. F of x, by the way, means y. Those are interchangeable. X is the term. The rate of change in this case is 6, because I'm changing by 6 every time. And 4 is my additional extra value added to my first term, or what the original starting point is. Let's try the last one. Try it yourself and then check it. You can pause the video. So in this case, 8 is my rate of change. I'm going to originate at -5. So 8 is the rate of change. I'm going to originate at -5. X is my term. Y, or f of x, is my value of my term. I'm going to use y this time instead of f of x, which is the same thing. You can put plus -5 or -5. So for the 10th term, it would be 8 times 10 plus -5, which would be 75. For the 20th, it would be 8 times 20 plus -5, which is 160 minus 5, 155, almost put 65. And for the 100th, it'd be 8 times 100 plus -5, which is 800 minus 5 is 795. Now we're going to change it up a little bit. We're going to take all the stuff we already figured out, and this time we're going to put it in a data table. And then we're going to use my algebraic equation to find the 820th term. So this is our first original sequence, 4, 8, 12, 16. We've already had a couple slides on this. The first column is my term number, or what number term do I want? What number term do I want? This is the output. This is what it equals. This is called the range. So range is what the term